Okay, hello everyone. Warm welcome to you for this new webinar of the webinar series on control education. It's a great pleasure for me today to introduce Steffi Knorn. She is a full professor at the Technical University of Berlin, and her research interests include the scalability of dynamical systems, control theory and its application, in particular in the biomedical system, if I'm not wrong, stability and analysis of two-dimensional systems and both Hamiltonian systems. But most of all, she's here today because she's the chair of the newly established IFAC Education Activities Committee. And so she has a large experience in control education, and today she will give a very interesting talk entitled Controlled Fun, Teaching Automatic Control Through Gamification. Before giving the stage to Steffi, I would like to tell you that the next webinar will be May 29th, and it will be given by Anthony Rossiter, and the webinar will be entitled A Custom Matter Toolbox for Teaching Control 101. So, Steffi, thank you very much for being here. The stage is yours.
Thank you very much for the introduction. Thank you very much for inviting me and allowing me to talk about this, which is quite unusual because I am talking about teaching in a quite different way, which is through gamification. Which I think is one of the most fun things that I do in my everyday job, so to speak. So I thought you might hear about it and get involved into it. And apart from the fact that I do my job, and especially also this part of the job because I like it, there's another motivation to look into this because we've got a problem when it comes to engineering or STEM in general, which is, first of all, we do have, at least in the Western countries, in many places, a low and even reducing interest in STEM subject. And that's quite a problem because we have many challenges, and at least in Germany, and I think in many Western countries, a huge shortage of engineers and technical personnel in general, which will even get worse because the gap between how many people in STEM and engineering we need and how many we are producing is even getting worse and worse. Part of that, which holds people back to study engineering in particular, I found, or also studies have found, to do with the fact that engineering is seen as something nerdy, and basically nerdy does not means attractive to some people. And to some it does, but to many people and too many it does not mean it's attractive. And also, when it comes to studying or deciding what to study, young people that have not been at university or have not much to do with university yet, they often go for what they already know from their surrounding, from their school, what is known in the general public. And when it comes to control, for example, even though it's basically everywhere, as we as control engineers know, there's very little known about this in general public, and that also creates a problem in terms of how visible our subject is. And when we then go into bachelor students' domain, and first time people are exposed to control, at least at TU Berlin, and basically at every uni where I worked so far, control was very often seen as the killer subject, the subject that students leave for quite long until the last moment, and very often it's the subject where students perceive it as to be the hardest and the hardest to pass in order to finish their degree. None of those bullets above there means that we're perceived as fun people or that our subject is perceived as fun. And that's maybe a problem because it tempers with the motivation. Does that mean we should not teach control in the usual or in traditional ways or in the ways we already teach control? No, not at all. Of course, we still need to teach control in a classroom to some extent because things like stability analysis, elaboration of theory, controller design, pole placement, and so on do need, of course, some solid basis. And there, for some of the aspects, it's really hard or maybe not the best way to teach it in a very different way. But So gamification is no substitute for that. Don't get me wrong and throw all your course material away. But I think gamification can be a complement. And it can be especially a complement not to necessarily teach the actual subject, but to generate positive emotions related to control. First of all, some interest and curiosity to learn more about it, but also to see that control can be fun, which hopefully enriches or enlarges your motivation to do something in order to learn more about it. So when I talk about gamification, maybe we should clarify what gamification is about. So here is the definition that I pulled out of Wikipedia 2 days ago, and it says, gamification is a strategic attempt to enhance systems, services, organizations, and activities by creating similar experiences to those experienced when playing games in order to motivate and engage users. This is generally accomplished through the application of game design elements and game principles in non-game contexts. So basically it means you take something which is not a game and you make it a game. Pretty simple. So what it's not like, it means no dry definitions and bureaucratic language or whatever, like this definition above. It's also quite different to our usual frontal teaching, but as I said, it should complement that, not substitute it. And it should not focus so much on the contents. So when we teach a course, we often are busy thinking about, okay, we need to teach this concept and we need to definitely make sure they understand blah, 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 blah. So there, the contents which we want to teach come first, and then we arrange the course around it. When you go for gamification, you think quite differently. First of all, one big motivation is that it has to be embedded into a story, and the story very often is pictures and funny, maybe a bit bizarre, and that's more important to have a fun story than to cover all the aspects and concepts that you'd like to cover. Then, as a definition says, it should include some game elements, of course, and very often game elements or game aspects also come with some sort of competition, even though I believe that one should be careful how much competition it should be in order not to make it unattractive for some users, again, that are maybe not too competitive. But some aspect of competition should be in there. And I thought I'd give you 2 examples of where we put this into practice and developed some gamified control teaching experiences. And the first one is a escape room. And now I need this feature with raising your hand or giving me a thumbs up. Please give me a thumbs up if you have played an escape room and you know what it is, and you have some basic understanding about the concept of an escape room. Some sort of, yeah, perfect. So I see about half of you having some knowledge about what an escape room is. Not everybody, so I think I'll give you a short overview. Oh, okay, but now I guess we are at 80% that have had some experience with escape rooms. So an escape room basically is very often a room, maybe it's 2-3 rooms that are connected, but it's a physical space, and you're locked into it. Not in reality, but in terms of, there's always a safety exit, of course, right? So you're locked into it, and there is some fictitious story that tells you why you're locked into that. And in order to get out of that, you have to solve puzzles to retrieve a code, find a hidden ledge or something in order to get out. And very often this is timed. So you play in a commercial escape room, you have 1 hour, and either you make it in an hour or less, or they get you out in order for the next group to get in. So that's the basic idea. And usually those escape rooms have absolutely nothing to do with control, of course, and very often they are not themed or made you to learn anything. They're just there for you to have fun, and that's perfectly fine. So we created an escape room for control, and we wanted to have an escape room which has something to do with control, but is still as accessible and as playable for non-control engineers as any other escape room. So we set the bar that Anything you need, any technical background should be at most at the level of an 8th or 9th grader, so 14, 15 years old. So basically no advanced maths, no Fourier analysis, no pole placement, no Lyapunov theory, okay? That was a bar, basically an upper bound of how complicated the puzzles can be. But then also we needed, as I said, we need to start with a story. So I'm going to get you through the basics of the story first. So the story starts with the university got hacked. And by the way, this is even funnier for people in Berlin, because during this time we were creating that escape room, the university in Berlin was hacked, and it was quite big in the German media because it was one of the first big hacks of universities in Germany. After that, many other or several others followed. And people that have something to do with that or have at least read the news reports know how this is not a funny thing, but making fun of it in this story. We started with the university got hacked, and there's a professor, happens to be the control professor, that has a plan to mitigate the attack. Why this professor has a plan to mitigate the attack doesn't matter, but she can't do it on her own. She needs your help, right? You, only option. Time is running out really fast, so there's, as I said, usually you only have some specified time frame, and the solution to mitigate the attack is a code that can stop the attack that's hidden in a box. Why there is a code to stop the attack doesn't matter. Why it's placed in this box doesn't matter. Only that matters is this box is for some reason located in the professor's house or lab, depending on how you tweak the story. We have two versions. And in order to help to mitigate the attack, you need to get to that box and retrieve the code and stop it. You only got 1 hour, because then everything is going to be too late. Unfortunately, the professor is really busy doing other things until then, so she can not give you exact information of where the box is located, where her lab is located, how to get anything. So she just gives you that and runs away, and basically that means you're on your own. So that's the story, and as you can already see, that the story does not make perfect sense, in the sense that why would a professor from this university that is being hacked have the code in this funny box in her office or lab or at home? That would make her very suspicious, of course. But in the saying of the story, players don't expect the story to be bulletproof, or it's the fun that is most important here. So people never complained about how this story is really suspicious. In order to engage with the story, we built actually this box. And this box here has this metal bar that is pulled all the way through, all the way to the left. And then every puzzle that you solve will have as a solution a code, a 4-digit code that you enter into this code pad. And then it will move this metal bar a tiny bit to the right, and once you solve the last puzzle and it's all the way to the right, you can open the box, and then we usually place a bit of chocolate and a folded piece of paper with some supposedly code on it in the box. So this is placed in the escape room, and that's the connection to the story about retrieving the code in order to mitigate the attack. So what are the puzzles? We wanted the puzzles to be related to control, but so each puzzle has something to do with one fundamental concept of control, but none of the puzzles is set up so that you have to know the concept, have understood the concept. You don't even have to be aware of the concept, right? But we created them having some concept in mind. So the first one is it's about a control loop, and in the video you see me holding a box. So basically we build boxes for a block diagram or a box diagram, right? And here it says, for example, plant or the German Regelstrecke on it, and you can connect them with cable. Those boxes are, there's one box for each part of a regular block diagram of a standard control loop that are placed somewhere in the room. Hidden, so you also have to get them out of cupboards and find them behind corners and so on, and also some cables which you all need to bring together and connect them. And once they're all connected correctly, one of those boxes will have a small display and detect that everything is connected correctly and give you a code that you can then enter into the box. It's the first puzzle you solve. Of course, if you know what a standard feedback loop looks like, you will be much quicker doing that. But if you don't, there's also hidden in the room a A4 sheet with a block diagram of a standard control loop, so that even if you have no idea what that means, you can just connect the cables in the same way it's shown on that drawing, and you can still solve that. That's the first one. The second puzzle is about feedback, where you close the feedback loop by communication between two players. So that is a puzzle where you have to be two people at least in order to play it. So here there is a board. You see here the board, and from the side you see on the one side there is a joystick, and that motion of the joystick will translate into the movement of some obstacle on the screen, but you can't move the joystick and see that at the same time. So somebody needs to stand here to move the joystick, and the other person has to give instructions, basically close the loop about more to the right, further up, blah, 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 in order to follow a trajectory. And once this is accomplished, then on the screen there will the screen will display a code that then again is the code to show that you solved that puzzle. There is a puzzle about dynamic systems where you don't need to know about dynamic systems. You just solve some basic equations which are on the level of a sixth grader's math, basically, or even less than that. It's basically +3 × 2 and stuff like that. And what you do is you solve the trajectory of the dynamic system, but you don't have to know that this is a dynamic system or what a dynamic system is even. Based on that puzzle, the next puzzle forces you to think about how you have to manipulate some values in the equations of the dynamic system in order to get to numbers, which basically it's about the movement of a robot, to make the robot move in a way you want it to be. Basically, that means it's state space, it's control in state space. But again, you don't even have to know that this is what you're doing. You just figure out the math and find out some numbers. Then we have one about stability, and I'm sure you all know the standard examples of stability where you have a ball-shaped or a flat surface or a round shape and then a ball placed onto this. So we made this a puzzle by having a fake lab instruction hidden in the room, and then 3 hats. One is a cowboy hat, one is a base cap, and one is shaped like this. And the instructions are to place the hat and balance a ball and figure out how far you can walk before the ball falls down. This has to do with stability, right? It's a standard example of stability, and but again, you don't have to know that this would be a standard example of a stable system where the ball cannot fall down because of the shape of the cowboy hat. Okay. We also have one for observer design, and I don't going to give you all details. I would love to, but I don't have time. I only tell you a little bit about this one because for German speakers, there's a pun involved here that I really like. So sampling is in German, it's called abtasten. And abtasten means also that you have to blindly touch something with your fingers carefully in order to figure out how it's formed. And here we build a box where you literally put your hands in, and at the back of the box inside there is a continuous curve that you need to touch with your fingers, and then you have to replicate that by putting pins of different lengths into the right order, so it on top of it. So you basically sample it, and in German that means abtasten, which you literally do with your hands. And if you do that, there are little contacts in the different pins. It will detect that and give you a code, and that shows that you solved the puzzle. There is a puzzle about PID control. We have one for systematic identification or regression, some frequency analysis one, and even one for aliasing that includes I think 27 houses that are drawn, which are supposed to be in a street. So we have 27 pictures of houses, 2 examples you see here, which are placed all on a wall, and a puzzle includes looking at those in detail. And this puzzle has to do with aliasing. Now you could say, well, fair enough. You got all those puzzles. You could have done them without or with control. Who cares if you don't know about control and you can still solve the puzzles? If you not even have to be aware of the underlying concept, then what point is there to have a control-themed escape room, right? Absolutely, very understandable and correct criticism. What we wanted to do is to engage people into this and also show them that this has to do with control afterwards. So what we did is we created a booklet that looks like this, which we hand out, one booklet per person after they finish the escape room. It has an overview of the included puzzles and what they have to do with control and real life. And then for each puzzle, you got 2 pages, looks like this, for example, with the text that explains in layman terms what this puzzle was about and what it has to be with control, and also how this particular control concept, how this is related to real life and where it's used in reality. For the people to first see, okay, control is maybe not that hard if I can do it in this escape room. Control is maybe fun because I really enjoyed the experience, and control is maybe really relevant because I see in this booklet how those things play an important role in many technical but also non-technical applications. So this is something where we close the loop, so to speak, in order to show people how all this has to do with automatic control. So that's our first example. That's something we created mostly in 2022. And the escape room now is placed at TU Berlin. So we have a physical room with the escape room, and we use it for example, for open days. And also I used that as a first prize for the people winning our advent calendar last year. So that brings me to my second example. That's an advent calendar that I created together with about 10 colleagues, or we were about 10 people in total from France, Germany, so it's more colleagues from TU Berlin, but also some colleagues from Hamburg, for example, Italy, Norway, Spain, and the UK. And we all joined to create this advent calendar. Before I go into more detail, can I use your ability to use the Teams buttons again? If you know what I mean when I say an advent calendar, can you give me a thumbs up? Okay. Oh, not too bad. Okay. So I guess we got some fewer people, but some already know. I would say about 30% have heard about an advent calendar, roughly. So I'll give you a quick idea about the concept. This is something that is, for some reason, pretty common in Germany, and I have not figured out yet how common it is in other countries. But the concept is obviously not limited to German-speaking background or anything. So. As you know, there are advent calendars where you open a little door and you have a picture or a piece of chocolate for each day from the 1st till the 24th of December in order to help you wait until Christmas and to enjoy the Advent season. And the Advent calendar I'm talking about is a little bit different. It's usually a website where every day from the 1st till the 24th, there is a picture, there's a question displayed, a multiple choice question, which is maybe a bit funny, can be solved with tinkering and thinking about it and playing around a bit. And every day you can answer the question. You can also answer it a little bit later, but every day a new question is available. And the idea is, or the aim is, to answer as many as you can correctly. And the person having the most correct, or if you have a draw of people, several people getting same amount of answers correct, then you can also look at how quickly they are able to answer the questions. And the idea is to do that well in order to win a prize. So in our case in Berlin, we handed out as a prize the opportunity to play the escape room or a bar of chocolate and stuff like that. We run that workshop not only in Germany, but also in Italy, Norway, Spain, and so on. So obviously for this, you need to create questions because as I said, if after or every day behind the door, there is a question. And we created those jointly. Every one of us created between 1 and 4 or 5 questions until we had enough and were able to fill the 24 doors. So the questions should be close to everyday life, and every day here should definitely be put in air quotes, because every day, whatever means, whatever fits into a story, and the stories could be as hilarious as and not making sense as the story for the escape room. It doesn't matter. People accept that the stories are a little bit funny sometimes, or as long as it's embedded in a story, and very often they actually do have to do with real life. Maybe not in that exact context. So, for example, one colleague created an example of a center needing to boil or to prepare a huge tank with liquid chocolate, let's say a ton. And of course, this is a realistic problem, but usually you would not have that much liquid chocolate. You would maybe have something else in this reactor, but still, it's embedded in the story. Then, again, same with the escape room. Every puzzle or every question was based on some fundamental concept of control. But again, also here, you didn't have to be aware of that even or know about the concept in order to solve the question. The questions were meant to be funny, and obviously we think they were funny. I hope the students did so too, or the participants. And again, here it's more important that the question is as maybe funny. Because it's an advent calendar, the questions were Christmas themed, so they included Santa, the elves, a sleigh, reindeer, and so on. And there's no need for it to be Christmas themed in an advent calendar. You could have something similar for a season leading up to another holiday, religious or not. So in our case, it was an advent calendar, but it doesn't have to be. But if it's an advent calendar, then the questions are usually Christmas themed. The questions are also multiple choice in order to allow for a very easy grading, because as in our case, we had in total a couple of hundred people participating, and you don't want to grade a question each day for 24 days in a row for a couple of hundred people. So obviously multiple choice. And that was actually the hardest. The question should be accessible in the sense that we tried very hard, or we had to put a lot of effort into making the question so that they do not include control lingo. They don't include transfer functions. They don't include any formulas if we can avoid it, so that people without a control background can even understand the question. Because if you've never heard about a Laplace transform and you get a transfer function h of s, that's it. The rest of the question will make absolutely no sense. And that created quite a bit of trouble for us, because we're so used in our general way of asking questions for exams or exercises that we have this lingo, and we ask about specific technical terms, or don't even bother about the context of it, that it was a good challenge for us to do it differently this time. Some students of ours complained because the questions, because of that, got much more wordy, because you need to describe the behavior of a plant, let's say, instead of just giving a transfer function or differential equation. But it was a good challenge, I would say. And I would also argue that's a good challenge for the students that otherwise would already know about control, because it forces them to think differently and to put those math equations and the different mathematical descriptions into different contexts and relate to what they actually mean. Plus, by using words as a description rather than formulas, it also allowed potentially people from without a control background even to even understand what the question is about. In order to tell, I think best to illustrate is I give you 2 questions from the Advent calendar. This one is the story, or the underlying story of the first one, which I guess you can read faster than I can read it out loud. Okay, so as you see here, this has to do with a steady state error, right? But it doesn't say steady state error. And even if you've never heard about steady state error, you can still, with thinking, find out the answer to this question. Did every child receive their present that magical night? And there are a couple of options to answer. The first one is yes, and Santa would even have quite some extra time to enjoy a bottle of Koskenkorva. And this happens to be liquor, so we thought it's maybe funny to have this picture of Santa then having maybe some schnapps in order to use the time that he would save. Second answer, alternatives is yes, but just in time. Then we've got no, the reindeer would fall just a bit short of the target. D, no, most children in the world would not receive presents at all. And E, and that's the last answer that's possible, no, I don't believe in Santa. And obviously this answer is wrong, but it's there just to be funny. So some of the answer alternatives were just there to be funny and maybe a little bit quirky. And believe it or not, some people, some people actually chose E just because it's funny. And I see Danny Abramovich saying, yeah, and one answer alternative could be Santa is not using the metric system. That would have been a funny way of doing it as well. Yeah, absolutely. Answers like this were absolutely okay. And sometimes we added them just to make the question a bit more quirky or funny. Here's another question that I wanted to show you. So you're given this picture of that globe. That's exactly the picture that was displayed. And the question was simply, which pole is stable? Now, you would argue that, hey, this is a lot of control lingo because what is a pole and so on, and what do we mean with stability? But now look at the answers that you can choose from. First one is, what do I know? I thought this advent calendar is about control and not geography. Second, of course, NP equals not stable pole and SP equals stable pole. C, due to global warming, the ice at the North Pole is melting, so unstable, whereas Antarctica is a continent and cannot melt away, so stable. D, of course, the North Pole is unstable because it's located in the right half plane, whereas the South Pole in the left half plane is stable. E, doesn't matter too much. In any case, these two poles show that the world is complex. And F, I'm unsure about this, so I'm planning to take some control courses in 2024 to learn more about it. In this case here, each of the answers was correct, and we awarded a point for each of them. Also, for each of the questions, once you put in your answer, you would get a text explaining what the correct answer is and also to which control concept it relates to. So what we did with this booklet for the escape room, we did for the advent calendar by the feedback you get after your answer. And that allowed us to tell people a little bit about control. And again, here we try to make it as layman terms or layman's language as possible so that people from a more diverse background can understand what we're talking about. So what are the lessons learned, which I like you to take home or take away from that talk? First of all, it's harder than you think. Coming up with good questions is really hard because it forces us academics to think very differently. It's quite challenging to put our control knowledge into very different contexts, and doing this without our normal way of talking and writing and describing things. Then it's also more work than you think, and also definitely more work than I thought at the beginning. I thought it's you can just do this in a couple of days, which is absolutely not the case. There is a lot more in terms of tweaking and thinking through and testing than I anticipated. But it's a way of reaching out in a very different way and attract people and get to talk to people about control, about engineering that otherwise you would have absolutely no access to. And even though it's hard and it takes time and it's so much fun, it was a great way of connecting to my team when we built the escape room, and it was a great way of working with my colleagues from these different European countries I mentioned earlier, because it was a very, very fun experience. And I personally have to say, apart from the fact that I'm a little bit nerdy and I love puzzles like this myself, so I enjoyed doing them, even though I could have as well just gone to an escape room here in Berlin or do some advent calendar for coding or math or physics or whatever and have basically the same fun, or maybe close to it. But I also do these things because even though only 10% of the questions or the puzzles that were created there make it into my regular teaching, it helps me to stay motivated to continue teaching in my traditional settings. It allows me to do something that's a bit out of the box, and that helps a lot in order to be motivated to go into the classroom. And also every now and then you do get ideas for exam and exercise questions that otherwise you would not have had, or different ways of explaining things. Yet the main motivation for me was for it to be funny. And if you want to do something like that, make sure you have got a team of people around you, because alone it's impossible. But you should definitely do it. It was definitely worth the time. So thank you very much. I'd be very happy to hear your questions and comments. And if you want to reach out later on via email, there's my address. Thanks very much.
Thank you very much, Steffi. Very interesting talk. So I will switch the registration off.
Yep. Do you